Alright, this lesson is about simplifying radicals, including square roots, cube roots. We'll be adding and subtracting, and we will also be multiplying these radicals and simplifying that. Alright, as I go through this, please try not to just copy off of me. It's better to watch me do it and learn how I do it, but then try to go back and do the whole problem by yourself. That's the only way you'll know if you really know what you're doing. Alright, so first of all, if I were you, I would deal with these negative signs. If you take the cube root of a negative number, the negative is just going to come outside the radical. Okay, so for example, if I have the cube root of negative 135, then that's just going to be the same thing as negative cube root of 135. Okay, negative just comes out. So if I do that, if this negative comes out, then that's going to make a negative times a negative, which is a positive. So what's really going to happen is this negative and this negative are going to basically cancel each other out. Alright, so it's going to be positive. So now, cube roots. Alright, now it's time to use our TI-30 XS multi-view. Okay, we need to know what perfect cube divides evenly into 135. So if we look at our table, alright, for example, so the first several perfect cubes are right here, 8, 27, 64, and you really want to go ahead and memorize this. Okay, memorize these first perfect cubes. So the question is, which one of these goes evenly into 135? Let's try 8 and 27. So we would just go, alright, 135 divided by 8. Alright, well that's a decimal, so that does not go in evenly. So what about 135 divided, whoops, what about 135 divided by 27? Okay, it turns out that goes in exactly 5 times. So that means I can rewrite this as I've got that 3. Okay, so this would be the same thing as the cube root. And we said this was 27 times 5. I'm going to put the 27 in red because that's the perfect cube here. 27 times 5. And then the rest of it, so I've got plus 3 cube root 5, nothing we can do with that. Now this 108, I wonder which one of these perfect cubes divides evenly into 108. Cube root, alright, so let's check that out. Alright, so 108 divided by 8, no. 108 divided by 27. Yes. Okay, so 27 again. So 108 is 27 times 4. Okay, now I put these in red because they are going to reduce and come outside the radical. Okay, cube root of 27. The cube root of 27 is 3. You can see it right on the chart. So that's why this is going to be, alright, I'm bringing down this 3. But then the cube root of 27 is 3 outside the radical. And then I'll bring down the rest of it. So this will be the cube root of 5. Okay, and then I've got plus 3 cube roots of 5 plus, alright, I'm just going to move this out of the way a bit. Okay, and again, so I've got this 3 that I'm just bringing down. The cube root of 27 is 3, and that's going to come outside the radical. Whoa. And multiply. Now this cube root of 4 is going to have to be stuck under the radical still. So when I put this stuff together, 3 times 3 is 9, so I will have 9 cube roots of 5 plus 3 cube roots of 5 plus 9 cube roots of 4. Now only 2 of these are like terms, guys. Alright, hopefully you can see that these 2 are like terms because they both have cube root of 5. Cube root of 4 cannot be added with these. But if I put these 2 together, 9 plus 3 is 12. So I'm going to have 12 cube roots of 5. Okay, plus 9, I'm just bringing this down, cube roots of 4. And that's as far as we can go because these are not like terms. So that would be the answer to number 1. Alright, let's take a look at number 2. Alright, these first 2 terms are already simplified as far as they can be. So I'm just going to copy them down unchanged. Now, when I look at this last one, 18, and notice this is a square root, not a cube root. So I'm thinking of perfect squares. Alright, and when I'm talking about perfect squares, I'm talking about this gray column here, 4, 9, 16, 25. Which one of these numbers divides evenly into 18? Alright, obviously 9 is a perfect square that divides into 18. Alright, that means I can rewrite 18 as 9 times 2. Alright, I'm going to put the 9 first because that's the perfect square which will be simplified. 9 times 2. Okay, and that once we simplify it, it's going to come outside of the radical. So everything in blue, I'm just going to copy as it is. So I've got negative 2 cube roots of 2. I've got negative 3 square roots of 2. And I've got positive 2. Now, the square root of 9 is 3. So that's going to come out of the radical and multiply. Alright, the square root of 2 is just going to be stuck where it is. Alright, so that's quickly going to become a 6. So this right here is 6. So maybe I'll just recopy it. So I've got negative 2 cube root 2, negative 3 square root 2, plus 6 square root 2. I'm looking for the like terms here. The like terms are here and here. Alright, because they both have square root of 2. If I put those together, negative 3 plus 6, that is positive 3. So positive 3 square roots of 2. And I'll just bring this one down. Negative 2 cube roots of 2. So that's as far as we can go. Alright, these are not like terms. Alright, because this is cube root and this is square root. So that's the answer to number 2. Alright, for number 3, I'm going to do really fast. It would work like this. 8, we're doing square root, so I need a perfect square. 8 is 4 times 2. Okay, keep that in mind. There's nothing I can do with the 3 square roots of 5. And then I've got my negative 2. Now 20 is 4 times 5. Okay, so I can put 4 times 5. Okay, so everything in blue is going to stay like it is. Everything in red is going to simplify and come outside of the radical and multiply if there's a number already there. So I'm going to have my negative. Now the square root of 4 is 2, and that's going to come outside of the radical. But this 2 is still inside the radical. Alright, this blue 3 radical 5 is not going anywhere. And then here's my negative 2, but the square root of 4 is 2. So it's going to come outside the radical and become the 2. all right? But the square root of 5 is not going anywhere, all right? It's just that the 4 came out. Square root of 4 is 2. Okay, so now I have, of course, negative 2 radical 2 plus 3 radical 5 minus 4, because 2 times 2 is 4, radical 5. Now, which of these are the like terms? All right, hopefully you can see that these two are my like terms. So if I put those together, positive 3 and negative 4 is negative 1 square roots of 5. Okay, we don't really write the 1 though, so we'll just say negative radical 5. And of course we'll bring down the negative 2 square roots of 2. These are not like terms. Alright, so this came from putting those two together. So that's as far as we can go with number 3. Okay. Looking at number 4, this one doesn't even need to be simplified. Alright, 3 square roots of 2 minus 5 square roots of 2. We can just go ahead and combine those. 3 minus 5 is negative 2. So that'll be negative 2 square roots of 2. Okay, let's look for number 5. Hold on. Okay, number 5, another easy one. They're already simplified. 4 plus 3 is 7, so this would be 7 square roots of 7. All right, just add the coefficients and keep the radical part the same. Okay, now we are multiplying. Okay, so we're switching gears. First of all, square root of 15. 15 is just 3 times 5. There's no perfect square in there, so it can't be simplified. But when you're multiplying, you don't need, you just need the same root, the same index, but the radicand, the number under the radical, does not have to be the same when you multiply. So this is like a 1. 1 times 2 is just 2. 15 times 3 is 45. So this will be 2 times the square root of 45. So hopefully you see I just multiplied the 1 and the 2 together, and I multiplied the 15 and the 3 together. Radical 15 and radical 3. Okay, and now I will go ahead and simplify like always. Square root of 45. What perfect square goes into 45? Right? Remember your perfect squares: 4, 9, 16, 25. Which one of these goes into 45? 9 does. Because 45 can be written as 9 times 5. So I'm going to put that 9 in red like I do. 9 times 5. Everything in blue is going to stay like it is. So I'm going to have my 2, and I'm going to have my square root of 5. But the 9 is going to simplify. Okay, the square root of 9 is 3. So, and that will multiply. So that's why the final answer is going to be 6 times the square root of 5. Okay, I'm going to squeeze one more problem into this video, and then we'll have to see if I have time to make any more videos later. Let's see. Let's go ahead and multiply these together. 8 times 10 is 80, so this would be square root of 80. Let me go ahead and demonstrate what the calculator can do. The calculator will not simplify cube roots for you, but it will simplify square roots. So if you are allowed to use a calculator, go ahead and use it. Okay, so 80, square root of 80 is 4 radical 5. So that's how you would use the calculator. Now, if I was going to do this without the calculator, I might have done it like this. Square root of 80. At first glance, I can immediately see that 4 goes into 80. So I might have thought to myself, okay, this is 4 times 20. Let me make this in red. I might have thought to myself, all right, this is 4 times 20. Okay, now the blue part is going to stay where it is. But that perfect square is going to reduce. Square root of 4 is 2. So that gives me 2 radical 20. But then I notice there's another perfect square. 4, there's still a 4 inside of 20. Okay, so what I have now is I've got the 2, but then square root of 20 can be written as 4 times 5. So again, everything in blue is going to stay where it is. So I'm going to have my 2, and I'm going to have my square root of 5. But I will simplify. The square root of 4 is 2 on the outside of the radical, and these will multiply. So that's why the final answer turns out to be 4 radical 5. Okay, that's how I probably would have done it. But that was pretty long. If you're allowed to use a calculator, why not use it? Okay, I think I still have time for another problem. Okay, looking at this, all right, there's a couple of things. There's more than one way that I could do this problem, but one way is, let's see, how do I want to do this? I'm seeing the square root of 9. That's already a perfect square, you know? So immediately I'm thinking, I don't want to mess with that because it's ready to go. But look at the 12. The 12 is 4, perfect square, times 3. Okay? Now, the square root of 9 is 3. Okay? On the outside of the radical. Or, you know, maybe I'll do that on the next step. All right, I'm just bringing down my square root of 9, which is already perfect. Now, everything in blue is going to stay like it is. So I've got my 4, and I've got my radical 3. Okay, but everything in red can now simplify because they are perfect squares. Square root of 4 is 2. And that's going to multiply. The square root of 9 is 3. All right, and that's already shown to be multiplying. So now let's just clean this up. 4 times 2 is 8. 8 times 3 is 24. So 4 times 2 times 3 is 24. So that's going to give us 24 radical 3. Now, I'm curious if the TI-30XS Multiview would have done all of this for us. Let's find out. So if I did 4 times the square root of 12, and then times the square root, times the square root, I better start that over, of 9. Okay, so that's just like what I have here. Let's see if it'll give me, okay, it actually does it. So great, 24 radical 3. So just know that your calculator will do this as well. Okay, all right, my planning period is almost over, so I'm about to run out of time. Let's see. Let me do one of these cube root problems. Okay, I'll do number 11. You know what? I don't want to go out of order. Yes, I will. All right, I'm just going to go ahead and skip to number 11. 576. Now, off the top of my head, I don't know which one of these perfect cubes goes into 576. Okay, so I'm going to use the calculator to help me. Okay, so notice I'm dealing with cubes. So 576. Is it divisible by 8? Oh, look, the first one worked. So 576 goes into 8 goes into 576 72 times. That means afraid my computer's crashing. No. No. Okay, so I've got the 7, and I've got this cube root, but we just saw that 576 could be written as 8 times 72. Okay, so everything in blue is going to stay how it is. So that would be 7, okay, and the cube root of 72. But the cube root of 8 is 2. Okay, so I have that. And 7 times 2 is 14. So that will give me 14 times the cube root of 72. Alright, but now we need to look at that 72. Alright, do any of these perfect cubes divide evenly into 72? Alright, does 8 or 27? Okay, I mean 72 we already know. 72 divided by 8 is 9. Okay, you know this. So 8 is that perfect cube. So you want to keep going here. So this is going to be 14, and then I've got that cube root, but 72 is, of course, 8 times 9. Okay, so everything in blue is going to stay where it is. So I'm going to have that 14, and then I'm going to have my cube root of 9. All right, but this 8, the cube root of 8 is 2. All right, and it's going to multiply. 14 times 2 is 28. So I should have 28 times the cube root of 9. All right, and that will be your answer to number 11. All right, that's all the video that I'm going to have time for today. I hope that was helpful. All right, any other questions we will address in class.